Gyronics.
Okay, so this one is very easy. So a pile of sand is in the form of a right circular cone of altitude 7 feet and slant height 25 feet. So what is the weight of the sand if the sand weighs 107.5 pound per cubic foot? Okay, so the rate is in cubic foot, which means we are going to calculate for the volume. So this is the visual representation of the cone, which has an altitude of 7 feet and a slant height of 25 feet. First, we need to calculate for the radius. So in order to do that, we need to draw the right triangle. Okay, so this is the unknown value, which is r. So we are going to calculate this using the, of course, Pythagorean theorem. Okay, so the hypotenuse is your slant height, so which means c squared is equal to l squared, and your r squared, for example, is your a squared plus h squared. Okay, so your b squared. And we can plug in other value, so l squared is equivalent to 25 squared equals, of course, unknown, r squared plus 7 squared. Okay, so we can transfer this 7 squared to the left side. So we have 25 squared minus 7 squared equals r squared. So r is the square root of 25 squared minus 7 squared, and this will give us 24 feet. So that is the radius of the cone. Okay, so we can now calculate for the volume. So let's refer to this given cone. Okay, so the formula for the volume of the cone is actually that is area of base and height, but 1/3. So where this 1/3 came from, if this cone is placed inside the cylinder, so the condition here is the radius of the cone and the cylinder are equal and with the same height. So this cone will take 1/3 of the volume of the cylinder. Okay, so we have volume equals 1/3 of base times height. Of course, base is the circle, so we have pi r squared. So 1/3 of pi r squared times height. Okay, so we are going to use this formula to our problem. So we have volume equals 1/3, of course, pi 24 squared. So since the radius is 24 times height, which is 7 feet, so this will give us the volume of this cone is 1,344 pi cubic feet. Okay, so we are ready now to calculate for the weight of this sand. So we have the volume of the cone, which is 1,344 pi cubic feet, and given to the problem is the density of the sand, which is 107.5 pound per cubic foot. So we simply multiply the volume to the rate and check the denominator. So we have cubic feet. So this two cancels out, and this will give us the weight of this cone, which is 453,897.90 pound. Okay, so this is the final answer, and see you on the next exercise.